Hello, welcome to today's webinar. We are happy to have you with us for this Getting to Zero session, Solving for the 11% Embodied Carbon in Buildings. I'm Connie Umphris, Communications Manager here at New Buildings Institute. Quick acknowledgement of the sponsors you see here. Their support of this webinar series provides ongoing opportunities for knowledge sharing around actionable solutions to drive the highest level of efficiency in buildings. First, you are muted. We cannot hear you. This helps keep the background noise down so that everyone can better hear the speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know, and we will help you as we go. We will take a few questions at the end of the presentation. Please ask questions in the same question pane. Please take a moment to answer the survey at the end of the webinar. We consider your input in the planning of future sessions. If you are seeking AIA credits, this survey is where you will share your AIA number for credit submission. The session is being recorded. All registrants will receive an email tomorrow with links to the recording and slides for the session. If you need a certificate of attendance for your records, it will also be part of tomorrow's follow-up. If you are not familiar with New Buildings Institute, we have been working in the energy efficiency space for nearly 25 years, working to make buildings better for people and the planet. Here is today's panel. I will be passing the mic over to David Kaneda, who will kick us off today. David is a senior NBI fellow and will be acting as our moderator. David?
Hi, everybody. I'm an electrical engineer with Ideas Consulting, and I'm really excited to introduce this topic today. Connie, I'm having there we go. Little problems advancing the slides, but it looks like it's working. So I just wanted to kind of give a little context and history here. This idea of decarbonization and looking at carbon, I think, really got going back in 2005 with a project that I was involved with, which was the Ideas Z² office building. So it was designed to be net zero energy and all electric, so no fossil fuel off the grid. And after that project, then there were a number of projects that followed that. Next slide. Office buildings, this is the Packard Foundation. Next slide. This is a water treatment facility, the offices and their research lab. Next slide. A public school. Next slide. A city environmental facility. Next slide. A number of public libraries have been done that are net zero energy. And next slide, even a DNA research facility. So as these projects started getting done, one of the things that happened, next slide, is that the cost of photovoltaics started really dropping. So that first project that I was involved with back in 2005, PV was something in the range of $10 a watt. Now it's less than $2. Next slide. And so we started seeing developers doing projects as for-profit developments that were targeting net zero energy. So this is one in Palo Alto. Next slide. This other one is RMI's, where RMI's headquartered in Boulder, Colorado. Next slide. And we even saw a series of existing building remodels that were done to be net zero energy that were also for-profit developments. This is one. Next slide. Second one nearby, and a third one after that. Next slide. So the next thing, that kind of big milestone, is that electric vehicles started getting popular and the cost of lithium ion batteries started dropping. Next slide. And so what we saw happening is that batteries started being installed to not so much to generate energy, but to store energy and then release it when peak demands happen. So it's actually done mostly to save money. So this is a project for El Camino Hospital that um, it stores energy and then releases it when the demand is high for this hospital facility. Next slide. And so what typically happens is the facility will have both batteries and solar. So the solar can help reduce those peaks during the day, but then toward the end of the day, when the sun starts going down, then batteries are used for that purpose. Next slide. So you can kind of get a sense of how that works toward the end of the day. Next slide. But the other thing that happens is if you have batteries, then actually you could potentially use the solar and the batteries if the grid fails. So that's a microgrid, and we've seen a lot of interest in some of these projects actually starting to be installed. Next slide. So this is a really interesting project in Hawaii for the school districts in Hawaii, where they had to put in air conditioning and the school electrical system wasn't robust enough to be able to provide all that power. So to save money from having to redo the whole school electrical system, the district put in batteries and photovoltaics locally near the air conditioning units. And they've done this in a number of schools in the state. Next slide. And more recently, I've been working with a tech client that's putting in a really large PV and battery microgrid, so they can both do demand charge shaving. They can look at how much carbon's on the grid and balance their reduce their carbon emissions and disconnect from the grid if the grid goes down. Next slide. So the other really interesting thing that happened, and this is where a lot of the presentation is focused on, is we realized that there's quite a bit of carbon involved in the materials in the building and building buildings. So what this graph is trying to show is the yellow is the carbon to build the building. So if you build a building in 2020, there's a certain amount of carbon in the materials and actually physically building the building. And then once the building's in use, the operation of the building releases carbon. So in this case, it's the average building, it takes something like 13 years or 12 years for the energy use of the building, the carbon related to that energy use to match the carbon embodied in the building just by building it. So the first time I heard about this was actually our building back in 2005. Next slide. Where the structural engineer, David Marr, was explaining that they're going to put fly ash in the concrete and that reduced the amount of cement, which saved carbon because there was something called pozzolans in the concrete. Next slide. And, in 2008, an architect named Larry Strain did this in-depth study. I had never seen anything like this before, where he was looking at the carbon and all the materials in the building and even the carbon from the workers driving to the site and things like that. Next slide. And so for this particular project, it was mostly wood construction, so a lot of the concrete ended up being in the slabs floor slabs of the buildings in the concrete. Next slide. So, if it's concrete, you could look at things like fly ash or trying to reduce the amount of cement in the concrete. If you're using steel, of course, recycling is a key way to reduce carbon. Next slide. And then, of course, if you could use renewable materials. So this is the same structural engineer, David Mark, did this crazy straw bale building that even had straw bale as parts of the structure. Next slide. And then most recently, we're just opening a project in the Silicon Valley that is, my understanding, the largest mass timber project in the country right now. So, using wood as the structure, of course, can reduce the carbon in buildings. Next slide.
Hi everyone, my name is Webley and I am a project manager at New Buildings Institute. I am an architect with 18 years of experience in the sustainable design and construction industry. And at NBI, I focus on promoting net zero building research through codes and policy development and market outreach. Recently, I've been conducting some research on incorporating embodied carbon into the building code. So I'm going to walk you through some of that today as soon as I figure out how to use the controls here. There we go. Connie kind of introduced us a little bit to NBI, so I won't share too much except to share what we call our 5 foundations. Together, these five foundations will help get us to a carbon neutral future. Each foundation has a really defined scope and a goal that will help us meet our 1.5 climate solutions. So I'll be presenting focused on that last requirement there, last but not least, I should say, life cycle impacts component. So as David discussed, our building codes have become more efficient. We've reduced our operational carbon. We still have more to go, but we're getting there. And the embodied carbon emissions has become a larger piece of that whole carbon pie on a building. So more people in the design and construction and even the product manufacturing industry are seeing that embodied carbon really needs to be addressed. And we've also seen this through third-party rating systems. They've been working on this for, I feel like, over 20 years at this point. They've been encouraging the evaluation of embodied carbon, of singular material, and whole building embodied carbon for decades. So because of the efforts made by these early adopters, we're able to have the conversations that we can today that has been able to look at codes and policies. So voluntary programs have been considering embodied carbon for years, as I mentioned. So half of the embodied carbon rating systems, if not more, address embodied carbon in some fashion, whether it's required or whether it's optional. So from LEED to Living Building Challenge, Green Globes, BREEAM, 3-star, and more. And many architecture firms have been documenting their embodied carbon within their projects, whether their clients are asking for it or not. Perkins & Will is making news by voluntarily designing to net zero embodied carbon. HOK and many other design professionals have been signing on to industry commitments like the SE 2050, which is the US Structural Engineers 2050 goal, and AIA's 2030 challenge for committing to track, reduce, and report embodied carbon. So those that are currently tracking and reporting embodied carbon are leading the way for future policy by providing us this really invaluable data. So we're starting to see this traction in the market to address embodied carbon head on. Instead of kind of through voluntary actions, we are working with codes and policies to address it. Carbon Leadership Forum, if you're not familiar with them, you should definitely check out their website. The bottom left corner here, you can see the website that you should be going to learn more about their policy toolkit. They also have this fantastic map here that shows the latest embodied carbon policies. Buy Clean California is probably the most popular policy. It's been replicated in other places like Washington, Minnesota, Colorado, which was just passed, and other places. The Buy Clean model requires that jurisdictional dollars are spent on specific products like steel and insulation that meet specific low carbon requirements. There are other policies. Portland, Oregon, where I am from, has a low carbon concrete incentive, which sets a global warming potential, or GWP, which is a term I'll be using pretty frequently. So global warming potential is in a way to present carbon CO2e, so carbon dioxide equivalent. Hawaii has a carbon dioxide mineralization concrete policy that requires that all state-funded projects that use concrete are required to include carbon capture. So that one's a little bit different. Quebec has a wood charter, which doesn't require that wood is used. It just requires that you consider wood on all publicly funded multifamily and infrastructure projects. And then there's other projects or policies that look at whole building life cycle analysis, which another term I'll use is LCA, so life cycle analysis. And Vancouver's green building policy for rezoning requires that all rezonings in Vancouver conduct a whole building life cycle analysis to study and report the embodied carbon in the projects. It does not set limits, it just requires reporting at this point. As I mentioned with the Buy Clean, the public embodied carbon policies use the power of the government spending to direct their dollars towards material specifications that meet their climate goals. So it's very tailored towards a specific climate. Where codes come in is that they really set a limit for all buildings. All buildings must comply, and it's a direct regulatory process. So this really sets rules that everyone, like no one can get out of it, essentially. We're no longer looking to just kind of nibble around the edges. We want to go full force and have all projects comply with embodied carbon requirements. And we really believe that we need that deep change to address our 5 foundations that I mentioned. So we have established building policies. They've done a great job at addressing energy. We have more to go, but we have these policies in place. We've got codes, we have zoning, building performance standards, jurisdictional building policies, etc. But these tools have not yet directly responded to carbon, and that's okay. We don't necessarily need new regulations. We can use our existing frameworks to address carbon, and that's what we are hoping to do. And it's also important to mention that the building code already regulates materials, so it's not a new thing. The building code explains the required characteristics of buildings, and it doesn't yet address carbon, but it could. So that's what we're hoping to address, is setting baseline for different materials. There we go. So we're looking at these 3 different opportunities to address upfront embodied carbon in codes. The first is EPD reporting, and another term I'll be using frequently is EPD, which is Environmental Product Declaration. And what we are suggesting here is that a specific percent of materials by either cost, weight, volume, or maybe even just a count, maybe it's 50 materials within the project provide EPDs. And this helps primes the market for what's coming and allows us to collect really important data that can inform these future steps, like the materials approach. So with the materials approach, we want to set specific targets that embodied carbon, that materials must meet specific embodied carbon requirements. So we might focus on the high global warming potential materials like concrete and metals at this point, or we could encourage low energy or low carbon manufacturing processes. And we're already seeing this with encouragement of programs like Energy Star and WaterSense. The third component that we're looking at is reducing overall embodied carbon compared to a baseline, and that's through a whole building LCA. So we could look at a % better than a specific baseline, or setting a carbon limit per floor area. The limit could be based on different product phases. So upfront embodied carbon, we could be looking at whole life carbon, which is everything from product manufacturing to end of life. So when it comes to environmental product declaration reporting, it's important to know that this is just a bare minimum. EPDs are a summary of the material life cycle analysis. It quantifies the impact of a product on the environment. They include information about the manufacturer, the product, the life cycle analysis, the methodology, material content, emissions, etc. But the EPD is really only data. The existence of an EPD does not mean that it meets a specific environmental standard. It might include or disclose information about a product, but it does not verify or that it meets a certification like Green Guard, for instance. But it might include information like the specific recycled content. The second approach is the materials approach. So we're interested in setting specific low embodied carbon requirements for materials at this point, and we really need the data to do that. So so that's why we're required, or why we are encouraging the collection of EPD to be able to have that data for materials, to be able to set, to be able to look at the data and set national trends. So in this example, it's an analysis of thousands of concrete EPDs from different regions in the US. And we evaluated the data to see if we could set a concrete global warming potential limits based on different regions in the US, or if we had the data to set that nationwide. So in this case, we're looking at 4,000 PSI concrete, so that's just a specific strength of concrete, to see what percentile to set that global warming potential limit. If we set that GWP too high, it won't do too much to reduce embodied carbon in concrete. But if we set that too low, manufacturers won't be able to comply, and then we're dealing with the variability based on regional materials. So global warming potential might not be the data point for every product. As I mentioned, we're also looking to include specific material manufacturing process that reduce embodied carbon in manufacturing. So for instance, Energy Star certifies cement, concrete, steel, and even cracker plants by evaluating their metrics. And that might be an appropriate way to look at code, similar to what we do with WaterSense and Energy Star for appliances. The third option is to look at whole building lifecycle analysis. So whole building LCA, as I might use that term frequently. So when we look at energy modeling, we are kind of past looking at the energy savings of a potential window. We're really looking at the energy efficiency of an envelope or the entire building. And we have baselines for that within energy modeling. And we can do the same thing when it comes to whole building embodied carbon. We can simply require that an LCA be done on a building, or we could set specific limits per building system or per the full building. So as I mentioned with the Vancouver, BC rezoning requirement, this is similar to this, where they're currently just requiring that an LCA be done, and we assume that in the future they'll be setting requirements for what that baseline must meet. The LCA offers a way to look at embodied carbon for a whole building. We'll see some examples of this in the future. But one of the largest benefits of the whole building LCA is the consideration of building reuse. where the first two options I looked at really look at new materials. The whole building LCA encourages reuse and has some historic and equity considerations, but there's also some negativity associated with that, which we won't get into today. But when it comes to reusing buildings, we're always concerned about asbestos and lead and other hazardous materials in those buildings. So at this point in our research, these are the three general recommendations that we're putting out there. We are getting more data as cities enact these EPD disclosure and regulate in different regulation around global warming for materials, so we can continue to refine any numbers that we put out there. And we can also plan to focus on those materials that have high embodied carbon, so concrete and steel. They typically account for about 50% of a building's embodied carbon. So addressing those is going to be essential. So here we have EPD reporting, where we're suggesting that 100% of all concrete and steel EPDs are reporting, and 75% of 4 different materials: flat glass, insulation, masonry units, and wood products. Within the materials approach, again, looking at how we can set those GWPs for concrete and steel, and then having the option at this point for whole building LCA. Not requiring it, but having a way if these other approaches don't work for a project. I should also mention that as I present this information on concrete, that this isn't the first time that concrete has been regulated in code. Marin County in the Bay Area was actually the first to set concrete global warming potential limits. And our intent with this approach was to provide different options. In Marin County, it is really based on global warming potential of concrete and cement. And here we're looking at a couple of other options. So we know that there's over 100 Energy Star cement and concrete facilities that are reducing their plants' energy consumption. So if we can encourage the use of those certified facilities, that could be a good compliance path. And since EPDs don't account for offsite renewable energy, we're evaluating if a product manufacturer could require renewable energy certificates to show that they are using a lower energy source. And then the last one is a global warming potential. So you can see here in the chart on the right, we have different global warming potential based on strength of concrete and then the type of concrete. So if we have early strength concrete or lightweight concrete. The last kind of details I'll show you here is based on steel. So similar to concrete, we have different options to comply. 80% of concrete could come from an Energy Star certified facility. It could include recycled content, but since much of the US market is meeting this requirement, is this really on par with some of the other performance requirements that we have here? And then also looking at that offsite renewable energy that a steel mill could use. And then also the embodied carbon requirements that I have shown here on the right. So just want to still reiterate that we are exploring these options. I absolutely welcome input via, feel free to email me. We're currently questioning if the recycled content will make the progress necessary to move the market, because it seems like the market is already there, but it also has a benefit of prioritizing US made steel. So that's a benefit in the US in some capacity. And we know that EPDs are a great industry standard, but they really aren't perfect. So how can we work with that standard, but also look at other options where the EPD is not addressing some of the environmental aspects that we'd want to see for reducing embodied carbon. And ideally, all large projects would actually conduct a whole building LCA, and we'd have consistent terminologies and baselines that would be used around the globe, but we're really not there yet. We're working with others, and we see how a low embodied carbon future is possible, but it's going to take all of us working together on it. So as I mentioned, we're still exploring these options. I welcome your comments. Feel free to email me or ask questions at the end of this. Thanks.
Thank you. This is Roland Hanseker. I greet you from Geneva, Switzerland. I'm with the World Business Council for Sustainable Development, Director for Built Environment. And I think, Webley, you could not have given a better handover than your last words in terms of whole life carbon assessment. And that's exactly what Chris Carroll from Arup and I will focus on in the next 15 minutes. Please, next slide. So WBCSD, we are a global member-led business organization with about 200 global companies. You can see the logos of these members from 23 different sectors, global coverage. And my focus particularly on the decarbonization of the built environment. Next slide. I think we all know these numbers, but it's still important to every time put them in front of ourselves. The built environment makes up 40% of global energy-related emissions, and I think it's a number that is still not sufficiently digested by all stakeholders. This is a massive sector and needs a really coordinated and collective response, as Webley has mentioned. And we see the importance of embodied carbon obviously going up. That stat that David showed at the beginning, that in the next 10 years, about 70% of emissions will come from embodied. And that leads us to these global targets that we're agreeing on with World Green Building Council, Global Alliance for Buildings and Construction, and others. We need to have by 2030. And that means have embodied carbon and have net zero in operation. That's a 2030 milestone. And by 2050, all buildings also existing need to be net zero across their whole life cycle. Next. Last year, we issued the Building System Carbon Framework together with our member companies, and it does two things. It looks at who are the key influencers over emissions in the built environment. So we know where emissions get caused through the manufacturing of materials, very little in construction, but really then mainly on the occupant side based on the energy use. But in green are players that do not have that carbon on their balance sheet, but they have an outsized influence over reducing. And on the right is the framework itself, which Chris will go into more detail. It proposes a simple reporting template. If we are able to report on emissions along the full life cycle of a building, we can also chart those reduction paths to get to net zero on the bottom right of this graph. If you could click one more time. So what this framework helps us do is to involve all actors with influence, address all the emissions, whole life cycle from embodied, and also including energy, and including the embodied carbon during refurbishment, which again, I think Chris will highlight to us that they play a significant importance as well along the life cycle, and really helping us to take on a performance-based approach that reduces these life cycle emissions. Next. This is what we published 2 weeks ago, and this is what will be much more detailed in Chris's presentation. So this importance of getting the data and showing the data openly and start setting clear targets. These are some of our main messages out of this work. And we're also attempting or daring a challenge that we believe that with focus and collaboration, building projects today already could probably have that upfront emissions footprint today or latest by 2030. Next. We issued another study that is quite related, but focuses on the investor and developers community. So how can those organizations that invest or develop projects, how can they set requirements along different stages of a project lifecycle? It is a practical report. You can see we have been supported on this by One-Click LCA based on their very large database, and also a lot of the leading example from the Nordic countries in Europe that are starting to set embodied carbon benchmarks. And so this study is looking at how investors, developers, but also tenants can set requirements in the earliest stages of their projects. We believe that with this, we can help send an additional signal to all stakeholders in the value chain and really work together to achieve those performances that are set from the outset. Next. Just a look ahead, we're gearing slowly but surely up to the COP26, and we'll be part of a group of global organizations helping to develop a built environment day. And we really want to highlight this importance of one voice and one ambition that we are able to reduce, and how the different organizations that are part of the race to zero, how they can really make a difference by reporting, measuring, setting targets, and really that radical collaboration that we need across the full value chain. So with that, I just wanted to introduce the context of the work we are doing, and now I'm handing over to Chris, who will walk us through the case studies in more detail. Thank you.
Okay, thank you, Roland. Briefly, for those who don't know, Arup is an independent, employee-owned, that's quite important, firm of designers, engineers and consultants working across all aspects of the built environment. We were founded 75 years ago in London by a Danish philosopher and engineer who you see on the screen, Ove Arup, and we've grown over time to be 15,000 employees in 89 offices working across 33 countries. Given the existential climate crisis we face, Arup have recently made a global commitment to put genuine sustainability at the heart of everything we do, and hence the statement, sustainable development is everything. I'm a director of Arup's building engineering group in London and Arup's UK net zero buildings leader. Next slide, please, Connie. Arup joined the WBCSD just over a year ago, and we were really keen to get involved in Roland's decarbonisation of the built environment programme and take a really hard look at net zero buildings and where we think the industry sits currently in relation to the required decarbonisation aligned with the Paris Agreement. So as Roland mentioned, nearly 40% of greenhouse gas emissions, which equates to 14 gigatons a year, are associated with the 5 billion meters squared of building floor plate that's built every year, city the size of Paris every week. A key asset we bring to our relationship and membership of the WBCSD actually is, as Arup, is our projects and the projects that we deliver, and hence we committed to the idea in our first year of producing some in-depth whole life carbon footprint case studies based around our projects. And we thought actually this would be relatively straightforward as a kind of introduction to the WBCSD, and we thought 6 consistent whole life carbon assessment projects would be a relatively straightforward thing to do, but it proved a lot more challenging than we expected. And I think this already tells us something important, and we'll come on to more on that later. Next slide, please, Connie. I'll go into a little detail in a minute, but we ask that you please download the report and go through it yourselves. Actually, there's a lot of data, a lot of information in the report, and we won't be able to cover it in any way here in this session, but please read it at your leisure. And there's actually very little published information on whole life carbon assessment, maybe with this clarity at present. One of the things we're pointing out is this needs to change rapidly. So we think this report is important because it's based on real, transparent data that's presented in a way where you can see exactly where the carbon sits across the whole life cycle of a project. And we, as Roland put on the screen earlier, we believe it draws out some very clear key messages that we have to move, and messages that reiterate what Webley was saying earlier, that we have to move rapidly to whole life carbon assessment of everything, all our projects at all stages. We have to develop and share carbon intensity data openly, so the EPDs, etc., that Webley was talking about. We have to develop and set clear global targets, and we have to much more precisely design what net zero buildings actually mean, and that you can't simply buy offset to claim net zero. You know, these buildings that are claiming to be net zero have to genuinely be reducing global greenhouse emissions, and we have to achieve wider collaboration across the whole industry. Next slide, please. Okay, this is the structure of the report. So there's an introductory section. The 6 case studies are summarised. There's a results and discussion section to the report where we talk across all of the results. We talk about the role of offsetting. We talk about some of the challenges, opportunities, and we draw out some conclusions. We hope that as you read the report, you would sympathise with the conclusions and draw similar conclusions yourself. And then we, as an appendix, we go into more detail in terms of the case studies and really put all the kind of assumptions and data that we've used, so that that can be used by others to maybe even compare and contrast projects that you have sight of. Next slide, please. Methodology does matter, and we wanted to be consistent across our 6 case studies, but we think also the industry as a whole needs to be consistent in how it presents and shares data in relation to the carbon footprint of the projects that we develop. With our work, we also wanted to support trialling the WBCSD framework for reporting whole life carbon assessment, and we wanted to be kind of part of developing a more common and clear methodology, promoting more sharing and development of good benchmarks and targets, and with all of that you can start to establish really good targets. Next slide, please. In a similar vein, the assumptions that are made are also important, and it's important that we start to share this information transparently. The data available at the moment, in both in terms of embodied carbon intensity factors and operational grid intensity decarbonisation, is very patchy, is quite limited, and we can't keep this as a barrier to reporting whole life carbon on our projects. So in parallel with all pushing for better data, we have to share and make best assumptions now until we fill the gaps. And that's what we've done here. And you'll see through these case studies, in some cases where we haven't precisely known data, we've used benchmarks, or we've used kind of best understanding as it stands. Next slide, please. And we've also taken a look within the report at benchmarks and where targets might sit in relation to those benchmarks. So there's a lot of, well, there's a necessity to establish where we are currently, and then if we're going to reduce 50%, what we're reducing 50% from. So here in the UK, there's been a reasonable amount of work around starting to establish benchmarks, both in terms of embodied carbon and setting targets against that, and also in terms of energy use intensity and setting targets against that. So as Roland said, the key premise to all of this is setting up the framework for us to reduce everything ideally by a half now, so to focus on really deep systematic reductions. Hold on a second, I'm just going to stop somebody hoovering. Sorry. Next slide, please. Yeah, so the case studies are we recognise in the case studies that there are only 6, so they're limited, and they're all Northern European projects. But that wasn't through a lack of trying to get US, East Asian projects from other parts of the world. It's just actually we couldn't get the data from these places. And these places seem to be less advanced maybe than some of the countries in Europe in terms of whole life carbon assessment. Hopefully a situation that's going to change rapidly. But I mean, for instance, in London here now, it's just become mandatory, pointing to what Webley was talking about. It's become mandatory over the last year in London to report LCA, life cycle carbon assessment, as part of the planning process. So you have to submit it with all new projects. Next slide, please. However, within the projects, we'd hope you'd recognise the projects as typical projects that you're working on, projects where the componentry, the types of systems are very similar to the stuff you're working on. But we would, we would make it clear that the projects all had some kind of focus on sustainability. PV cells we used. One of the projects is timber, high performance facades. 2 of the projects are retrofit projects where the existing structural frame has been retained. So you could argue that these are the upper percentile projects in terms of maybe where things sit globally, but maybe that doesn't matter in terms of the assessment now. I think it's still important to see the data clearly. Next project, next slide, sorry. Sorry, Connie. Thanks. So this is one of the. Sorry, can you go back? Yeah, this is one of the case studies in the report and shows how the information is presented. This is a typical office building development in central London. It's pretty much complete now. The projects have been anonymised, which is why we show a cartoon of the project based on general client requests. Maybe as things become clearer over the next few years, clients might be a little bit less sensitive about sharing this type of data, but for the moment we anonymised all of the projects in the report. So there's a description of each of the 6. Next slide. And we are clear in our kind of description, the information that we provide, what the assumptions are, what the data is that we've used in building up these whole life carbon assessments in terms of the carbon intensity of the concrete that's been used, type of concrete, how much cement replacement, type of facade, or types of finishes, raised floors, heating systems, etc. Also the energy use intensity, and we've also pointed to what we know about the grid intensities and decarbonizations of the energy systems in the various geographies that we've looked at. We've used one-click software to pull the data together, primarily because it's one of the only few certified LCA calculators that we can use in the UK as part of the projects that we have to submit as from a mandatory perspective. Next slide. So I realise there's a lot of data here, and I'm not expecting people to read it all. And again, urge you to go back and have a look at the report in more detail at your leisure. This is the example presented in the WBCSD framework format, and the importance here is, I guess, filling in all of the boxes in this framework. So having the whole picture, not just a partial picture, and then seeing how that picture also builds up in the various life cycle stages, from the 545 kilos of carbon per square meter at up front at the end of construction, through the embodied carbon that's built up through the maintenance refurbishment cycles during the life frame, which adds about another 60% embodied carbon, and then comparing that and contrasting that in the context of the whole life cycle and the operational carbon. And this is actually a project. This particular project was a project that had a very heavy focus on embodied carbon, especially upfront embodied carbon, but maybe not quite such a focus on the operational side. Next slide. Yeah, and then we go into the results and discussion, break that down into 4 main sections. Next slide, please. And here we start to compare and contrast some of the projects. The number on the left-hand side here is the average across the 6 projects, and obviously the projects vary in terms of their typology, but this number seems to be, a reasonable kind of datum across them all, in terms of something that is definitely achievable in the context of these particular projects. Next slide. And you start to see again the average gets built up as you look at the different life cycles. Next slide. And we see the range of kind of operational operational carbon, energy use intensity turned into carbon across the various projects, and there's quite a range to those. And we're clear in looking at this that we need kind of better methodologies in terms of measuring the total demand. And actually what we really need is more data on how buildings operate. So only one of these projects had 3 years worth of energy bills that we could use to really assess what the energy use was. And we, as we go forward, we need to do much more of that work post occupancy, back checking against our design calculations. Next slide, please. And here you see the 6 case studies compared against each other, where their average sits at about 1.8 tons of carbon per square meter as an overall whole life carbon footprint, and a suggestion that, if we're looking to halve that, what that might start to look like. Next slide, please. On that slide, on the previous slide, we also see, and we see here that per the claim made earlier, across these case studies, the embodied carbon, especially when considered in the context of its whole life, is equal to the operational carbon. And I think importantly, we represent the results here as a timeline, and importantly, the embodied carbon up front, the A1 to A5, hits the atmosphere immediately and you can see the quantum of that. So, you know, we have to look to reduce that. There has to be a real focus on reducing that as an absolute priority, and reducing that is to, you know, build less, use less material towards bringing demand down to cleaner supply, and that's true for both embodied carbon and operational carbon. Next slide. Nearly at the end here. We break down the kind of materials. Again, this plays very well to what Webley was talking about earlier. A relatively small number of materials have a very significant impact, and we also look at in the report direct offsetting via things like sequestration. So the timber project we have, what if we consider the carbon that's locked up in the design, what effect that might have. We consider the after kind of life benefits of potentially recycling the materials or reusing the materials, and we you know, the use of renewables on site. Next slide, please. And this is the last slide, which again is a repeat of the key messages that we believe that came from the report, and a kind of overall graphic that shows where we think the carbon sits in relation to the whole life cycle, you know, as a general average across these projects, to give you an idea of what the quantums are. But we feel we have to commit to whole life carbon assessments on all projects. We have to develop consistent carbon intensity and benchmark data. We have to get to explicit targets, not just notional reductions, and better design net zero and collaborate to do that. I realise I've overrun a little bit, but apologies. There was quite a lot to get through, and somebody started hoovering in the office partway through.
Aurora?
Lovely. Hi, everybody. Thanks so much, Chris. That was lovely to see. My name is Aurora Jensen. I'm joining you all from Bureau Happold Engineering. I sit in our New York office as a sustainability engineer. And my role is typically to lead the whole building lifecycle assessments we're running on our projects, as well as, and I'm an energy modeler, so I work also on the operational side of the picture. For context, Bureau Happold is a global multidisciplinary consulting engineering firm. And we're really focused on some large-scale targets around operational and embodied carbon. We aim to be net zero carbon in our projects by 2030 and reduce the embodied carbon in our projects by 2050. All right, so my focus with this piece of the presentation is to really zoom in into the design process itself for how you might tackle operational and embodied carbon on your projects and what it looks like to do so. I'm going to do that by providing two examples at the system scale and then at the whole building scale for what that might look like. But to start and to frame this conversation, I wanted to share a quick graphic for how embodied and operational carbon come together to help our pathway to decarbonization. So simply put, this graphic on the right starts with some kind of baseline building. This is difficult to define, as we have seen through the presentations previously, but you need something to benchmark and target against. And then from there, you typically look at your passive design principles, approaches to electrification or active systems to reduce your whole building energy consumption. And then you would offset the remainder with on-site or offsite renewables. And then you take a hard look at the embodied carbon impacts in your building, make as many reductions as is feasible, and then offset the remainder with RECs. So in the US context, particularly thinking about frameworks like the Living Building Challenge, this is typically what we mean when we're talking about decarbonization on our projects. Go ahead. So the first example I want to share, like I said, is at a system scale. So this is looking at the consideration of a battery storage system on a relatively large project. So in order to investigate battery storage, we have to consider carbon intensity, but on an annual and hourly basis. So rather than a coarse comparison from a yearly scale, to understand the influence of a battery, we need to look at daily behavior of charging and discharging that battery. So to do that, we looked at using carbon intensity profiles from this provider called WattTime. This is particularly relevant in the US context, but WattTime provides these normalized annual profiles for carbon intensity for your local grid systems. And this, we'll go to the next slide. We can look at what this looks like from an annual basis. This plays really nicely with results from an energy model because it's also normalized by an hour-by-hour basis. And you can see the flux you can observe over the course of the day, as well as over the course of months in this file. And this has to do with the underlying conditions and the operational decisions being made at the grid scale. But some of that is compressed and captured in this normalized profile here. You can think of it almost like a TMY file that we typically use for representing average weather data over time. Go ahead. Looking at a typical day, you can dissect exactly what the constants are looking like, early in the morning, late in the afternoon, and begin to understand when it would be beneficial to a wider carbon picture if you were to charge or discharge a battery system at different times of day. Go ahead. And for this study, we really designed two possible pathways. First of all, our baseline is not having a battery system. The second option would be having a battery system, but charging it based on when it's best for your cost. So that has to do with the demand structure of the local grid. And then the second option would be optimizing based on carbon. I'll say both of these models were simply managed for this project. So these aren't detailed algorithms. These are like simple spreadsheet-based models for estimating these charge and discharge times. And what we found, looking on the right, is that these savings are extremely modest. We're seeing a slight benefit on an annual basis if you're charging for carbon, when the grid is lowest in terms of carbon, and a slight penalty if you're charging when it's best for cost. So that's actually interesting to observe. But I think overall, these impacts are quite small. And part of the reason for that is because there's also an energy penalty when you charge and discharge a battery due to a loss based on its efficiency. Go ahead. The other layer we wanted to consider in this study is the embodied carbon of this battery storage system. So not even looking at a whole building life cycle assessment or anything that involved, this was a really zoomed in approach for what's the likely footprint of this battery system that we're considering. And we used generally available research to estimate, what is this battery chemistry likely to be, and what does the research say is the footprint associated with that system. And you can see here we've estimated the tons of CO2 equivalent that's associated with this 8 megawatt system. Go ahead. And here you're going to see we're overlaying the operational and the embodied impacts. I'm seeing the slide get off a touch on the right, but really it's interesting to observe that because of the intensity of the embodied carbon portion of the impact, really this battery may be important to the project for many reasons, but it's not likely to be a carbon savings over the lifetime of the building based on this analysis. And that of course has to do with battery efficiency and as well as the replacement rate. So we were assuming this battery has to get replaced at regular intervals. So you can see regardless of how you charge it, you're really not able to overcome the operational, the embodied carbon embedded in this system. And then last slide here. So something to consider if this battery system is still important to the project, say for resiliency measures or other goals that the project might have, you might consider tackling this by sourcing your battery differently or thinking about your procurement requirements. You might look at alternative battery chemistries. You might investigate a longer or extended warranty on that battery. We also considered, what does this replacement rate look like, and how might you make that replacement with a recycled battery instead of a fully novel product. So we started to estimate what this reduction might look like. But this was a way of thinking through how we can mediate some of this impact if we're going to go this direction in the project. All right, so the last example I want to share is really at the whole building scale. And again, it's about linking the operational and the embodied picture for this project as a whole. This is the Fossil Park project. It's a really exciting children's museum in New Jersey, and it's seeking living building energy pedal certification. Go ahead. I think I'll treat this briefly because I know we are limited on time. So of course, our strategy from a high level is to integrate our passive approach with our active strategies and our renewables to get that whole building picture that many of the previous speakers have spoken to. Go ahead. In terms of passive design, you can see here we're starting to estimate the savings from a baseline case associated with higher performing facade systems. So here we're able to estimate if you pick a higher performing facade, you are likely to achieve a certain amount of reduction in your whole building annual energy consumption. And we use this to make recommendations to our clients about what the benefits are of choosing these higher performing systems. Go ahead. We then escalate this analysis to the active systems as well. So very early, this was a schematic comparison. We were looking at, baseline traditional systems compared to a fully electric options for air source heat pumps or ground source heat pumps. And we could really clearly make the case for this in energy terms. Next. Moving into design development, once we were able to make the case that electric was the pathway that the building should achieve, particularly if they're interested in living building challenge, which doesn't permit combustion on site, we then went about further developing the ground source heat pump comparison. So this really investigated 4 different ways of configuring the ground source heat pump systems. So we're really in the details here, investigating how this is going to work and what kinds of energy benefits we might have for some of these better configurations. While we didn't explicitly study embodied carbon, you can also see that modules or options C and D noted on this slide are only 3 modules instead of 6. I mean, you could imagine that would come with an embodied carbon benefit as well. And taking this energy analysis, what we're typically doing is converting to operational carbon for a study at this scale, just using a simple kilograms of CO2 per energy unit constant. So that's a contrast from the battery storage study where we really needed that carbon data to be at an hourly resolution. This was a case where we can use that annual resolution. All right, so a thing to consider about this building is it's largely a concrete structural system with a lot of exposed concrete in the interiors. And part of what that benefit is, next slide, is really about how that performs passively. So when you have exposed concrete in your structure, you're able to actually use that concrete as a heat source and a heat sink. It basically stores and releases heat naturally because of its thermal capacity. And that results in a dampening behavior for the internal temperatures in that space. Go ahead. And we used this behavior to help demonstrate the passive survivability requirements for Living Building Challenge. And this was important because you need to be able to show that in an emergency scenario, people could shelter in this building without experiencing hypothermia or hyperthermia. So this was kind of a temperature condition we needed to satisfy. Go ahead. And what that looked like is basically taking our energy model, turning off the mechanical systems and leaving on minimal internal gains and seeing, are we satisfying these conditions in a 10-day free running mode? And you can see in the hottest week in the year on the left, we are not exceeding that 86-degree max, although we get close. And on the right, in the coldest week of the year, we are falling in temperature, but we don't achieve we don't hit that 54-degree minimum where we'd start to get concerned about anybody being in the space. So of course, while concrete is beneficial from a thermal mass perspective, it is really the driver for the embodied carbon picture. And that was the final piece of this analysis I'll share before closeout. So in estimating the whole building embodied carbon, we created these graphics to help us understand where the biggest proportion of the building impact is sitting. So if we look at the breakdown by material, reading left to right, these are sort of nested categories. So on the right, you can see about 2/3 of the building is structure and foundations, and the last third is enclosure. Interiors were omitted for this round of the analysis. As you move to the center, the material category bar, sorry about that, you can see that concrete and metals are substantial contributors, absolutely enormous. And then on the graphic on the right, we start to identify what portions of the building are responsible for this. So rather than just saying it's the structural concrete, what parts of the structural concrete? Well, it's the concrete walls and the elevated slabs, and this gives us great information for intervening in the design. And this directly translates, go ahead, thanks, into the series of reductions we have recommended and have included in our specifications and approach moving forward in the design. So starting with the baseline building, we then suggested introducing a minimum of 40% SCMs, which are supplementary cementitious materials, in the structural concrete mix. We suggested they reduce the major interior wall, that they introduce certified wood, as well as specifying a low carbon rebar product through kind of a max GWP limit in their specs. So this together became a package of opportunities in the design that could meet that 20% reduction that was feasible for the project. All right, in closing, I wanted to just share, this is more exploratory. I think it points back to Chris's and Roland's explanation before, but we want to start considering what this looks like from a whole carbon perspective on a project. And this is by no means comprehensive. There are, of course, phases missing and pieces of the building missing, including mechanical systems. But doing what we could on this project, you can see that we're making a huge difference from a typical case, which basically describes our baselines, to a high performance case, which includes all of the reductions we're making in our day-to-day design decisions. And then the living building green bar shows the inclusion of those renewables and the offsets from the RECs, which really brings our total very, very low. And the last thing I'll say is this upfront spike during construction associated with embodied carbon is really critical. And that's why it matters, and we need to consider it early in the design process. So thanks so much for having us, and I'll conclude there.
Thank you, everybody. That was fantastic. If you could turn on your cameras real quick for our last couple minutes, we'll just, we've got a few quick questions that have come in that I'd like to bring forward, and then we'll be done. So one of the questions was, just as EUI gives a baseline to operating energy, is there a similar baseline value being developed for embodied carbon? And you guys can just take this as you feel necessary.
I think it depends where you are in the world in terms of that question. So that you're starting to see limits emerge, but I think more work needs to be done and published, like the work that we have put into the report, to give people the confidence of where to set, business as usual benchmarks, and ideally the kind of the targets, the reduction targets that need to be associated with those, and we would hope that that's going to emerge rapidly over the next couple of years, and urge people to share more and more information in this arena, especially in an open source way.
Okay. So this question actually, nice segue, Chris, even though you didn't know it. Many manufacturers are arguing that the inconsistency of embodied carbon reporting is evidence that various industries are not ready for the reporting. How do we overcome established industry pushback against that tracking? There is a lot of lobbying for the status quo.
I'll let somebody else go first. If everybody's silent, I don't mind chipping in.
I can jump in here and share that industry generally will comply with what they need to comply with. And I think that there's also a policy play in here as well for jurisdictions to provide some sort of support for smaller businesses, however that's defined, to be able to provide some of the reporting that's necessary. So whether that, so I should say that here in Oregon, DEQ is helping some of the smaller concrete manufacturers develop EPDs. So that's really helpful for our industry in Oregon to be able to provide concrete EPDs that meet specific requirements. So I think more support like that is necessary.
And I think, to be blunt, you also need legislation as well to go hand in hand with that. So we're seeing here in London, I think, as I mentioned earlier, LCAs are becoming compulsory as part of the planning process, and that drives a requirement to put the data in. I think we also shouldn't be kind of paralysed ourselves as practitioners, not having all of the data perfect, in a perfect form. We should use benchmarks. We should use best available data that we have, kind of, to fill in while that data gets richer and more accurate. And the analogy I would always use is cost. I mean, the idea that you build a building and not know how much it cost in dollars would seem crazy, but we don't know how much it costs in carbon, so we can apply exactly the same process as we apply to costing commercially as we do to costing carbon. And before an early stage in a project, in terms of dollar cost, you make assessments, you make judgments, you use benchmarks, you use precedents, and we have to move to do that quickly as a stopgap to having really, really fine-grained, precise data.
All right, does anybody want to add anything here? We are out of time, and I was going to close this out. All right, I'll take the silence as. All right, so here we are at the end of the session. We have our Getting to Zero Forum is happening this October, and it is currently, our early bird registration prices have been extended to August 9th. So if you were hoping to catch those early bird prices, you have a couple extra weeks. If you are looking for more information on getting to zero carbon and energy, you can access our Getting to Zero resource hub for some open source resources for you as you go on the zero journey. Find out first, follow us on social media. We have a new Instagram account that you can follow us, and a new Twitter handle. So check us out on social media. And tomorrow you will receive a link to the on-demand recording here and a PDF of the slides. Thank you all so much. Great presentation, everybody. Have a fantastic day.
Thank you for having us.
Thank you.
Thanks.
Thank you. Bye.
Thanks.